Okay, good morning. Today's topic will be your subject, Electronics 1. Topic will be cover rectifiers, and we'll have a discussion in this module number 3. Okay, let's start. I'm your OLC from Engineering Department. Good morning. Okay, as you can see in this discussion, we will discuss a rectifier with the history. The diode has a characteristic to conduct current in one direction and block current in other direction. Okay, depende yun sa biasing kasi. For example, kung ang diode, ang characteristic nito is mag-conduct current in one direction, it means is in the forward bias. And it's a block current in other direction also. That is in the reverse bias. Depende sa biasing. That's why diode has two characteristics. It can conduct current in one direction and block current in the other direction. This is the reason diodes are used as rectifiers. Okay? Yun kasi yung reason bakit ginagamit natin yung diode as a rectifier because it can conduct current in one direction and can block current in another direction. Then rectifier also convert AC voltage into a DC voltage. Okay? They can be found in all DC power supplies that operate from an AC voltage source. A power supply is essential part of an electronic system. Okay? Ibig sabihin, yun nga yung rectifier, the definition, it can convert AC voltage into DC voltage. I-convert nito. Then, it can be found in all DC power supplies that operate from AC voltage source. Then, a power supply also is an essential part of electronic system. Okay, today's learning outcome for this conclusion, we will explain and analyze rectifiers and its operation. Then we'll also discuss half wave and a full wave rectifier. Then we will also discuss determine average value. Then calculate output voltage, and we will define the peak inverse voltage. Okay. Let's start for this definition of half-wave rectifiers. As shown in the figure is a circuit for a half-wave rectifier. A diode is connected to the AC source and to a load resistor. It is better to examine what happens in the circuit to understand why it's called half-wave rectifier. Okay, ganito yung schematic circuit natin for a half-wave rectifier. Okay, as you can see, we have a circuit for a half-wave rectifier. It consists of a diode that is connected to the AC source with the positive, and it's connected also to a load resistor. And it's better to examine what happened in the circuit to understand why it's called a half-wave rectifier. Okay, that is half-wave rectifier circuit. Continuation. As you can see in shown in the figure above, is what happens during the positive alternation of the input voltage using the ideal diode model. Okay, as you can see, these are the positive alternation of the input voltage. Then using an ideal diode model, we can see that when a sinusoidal input voltage Bin, okay, goes positive, the diode is in the forward bias. Pag forward bias is, it can conduct current through the load resistor. Okay? Then the current produces at the output voltage across the RL, which has the same shape as the positive half cycle of the input voltage. Okay, ganito na yung itsura ng yung ating output voltage na. Kasi nga ito is naging positive half cycle of the input voltage. Okay, same shape din siya. Na-cut lang, kumbaga naging ano lang to, naging produce an output voltage. Okay. That is the positive alteration of the 60 Hz input voltage. Okay, continuation. Kung kanina ito is naka-forward bias, dito naman sa next example natin is, as shown in the figure, is what happened during the negative alternation naman. Kung kanina is naka-positive alternation, ito, nakat. Dito naman is negative alternation of the 60 Hz input voltage. As shown in the figure is what happened during the negative alternation of the input voltage using the ideal diode model when the sinusoidal input voltage, okay, yung BN natin, goes negative, then ang magiging circuit nito is magiging yung diode the diode is in the reverse bias and there is no current, okay? Since yung sinusoidal input voltage natin dito, Bin goes negative, then the diode is in the reverse bias and there is no current. That is, walang current na nagflow dito. Then, the voltage across the load resistor, yung voltage na mapupunta dito, is equivalent to 0 volts. Then the net result is that only the positive half cycles of the AC input voltage appear across the load. Okay? Yung positive half cycle lang makikita natin sa input voltage across the load. And the voltage across the load resistor is equivalent to 0 volts. Okay, that is in the reverse bias, yung diode natin. And there's no current. Okay, how about the average value of this V average or the V average value of the voltage is equivalent to Vp over pi. Constant na yung value na yan. Divide lang natin yung peak voltage divided by the pi para makuha natin yung average value ng voltage. Okay, now these are the effect of a half-wave rectifier output. As shown in the figure or above is what happened when the practical diode model is used with the barrier potential of 0.7 volts. During the positive half cycle, the input voltage must overcome the barrier potential before the diode becomes the forward bias. Then this results in a half-wave output as shown in the equation above. Okay, as shown in the figure above, kasi yung practical diode natin model, ang barrier potential ng 0.7 usually kung silicon yung pinagkagamitan, 0.70 volts ang barrier potential. Ang mangyayari or ang condition is during the positive half cycle, the input voltage must overcome the barrier potential. Mas malampasan niya dapat yung value na 0.7 before the diode becomes forward bias. Bago mag-forward bias itong diode natin na nandito. Then ang magiging result is this one, yung output niya. This will become the results in half-wave output. Okay, then the equation for a peak voltage output is equivalent to input peak voltage minus natin doon sa barrier potential na 0.70 volts. Okay, that is for the effect of the barrier potential on the half-wave rectified output voltage. Now we will discuss the peak inverse voltage or yung tinatawag nating PIV. PIV is equivalent to input peak voltage. Equal lang silang dalawa. Okay, let's discuss. Peak inverse voltage is equal to the peak value of the input voltage and the diode must be capable of withstanding the amount of repetitive reverse voltage. Okay, equal lang yung dalawa since yung value ng peak inverse voltage is also equal to input peak voltage is the peak inverse voltage equals to peak value of the input voltage and the diode must be capable of withstanding this amount of repetitive reverse voltage. Okay. That is the peak inverse voltage. Okay, now we will discuss the peak inverse voltage occurs at the peak of each negative pole cycle. As shown figure above, the maximum value of the reverse voltage designated as a PIV or peak inverse voltage occurs at the peak of each negative alternation of the input voltage when the diode is reverse bias. Okay, ano nangyayari kapag peak inverse voltage is meron siyang negative alternation or okay, ang nangyayari kasi yung maximum value ng reverse voltage designated as a PIV or peak inverse voltage is occurs at the peak of each negative alternation of the input voltage when the diode is reverse biased. Okay? Okay, ito naman yung tinatawag nating transformer coupling. Okay, ano ba yung transformer coupling? As you can see, we are familiarized with the transformer application. As shown in the figure above, a transformer is used to couple the input voltage from the source to the rectifier. Then the transformer allows the source voltage to be stepped down as needed, and the AC source is electrically isolated from the rectifier to prevent shock hazard in the secondary circuit. Okay, ganito yung application ng transformer. Usually, yung transformer is ginagamit natin para makouple yung input voltage natin from the source ng rectifier. Okay, since kinonvert na yon para maging DC, from AC to DC, okay, then ang rectifier kasi, okay, naging DC, AC to DC. Okay, as you can see, the transformer, meron kasi type ng transformer dalawa. Depende kung step down or step up. Pag step up kasi, ibig sabihin tinaas niya yung value ng voltage nun. Katulad dito sa example is step down, ibig sabihin binaba niya yung value. For example, in this one, the transformer allows the source voltage to be step down as needed, and the AC source is electrically isolated from the rectifier, then to prevent shock hazard in the secondary circuit. Okay, that is the transformer. Okay, I'll just check this one, your lecture. Okay, let's continue. How about the transformer coupling? The turn ratio of the transformer determines the amount of the step-down voltage. A transformer with a turn ratio is greater than 1 is a step-up type, and one with a turn ratio less than 1 is a step-down type. Okay, as you can see, ang ratio kasi natin dito sa transformer, we have the, for example, the turn ratio of a transformer determines the amount of the step-down voltage. Then we have a transformer with a turn ratio greater than 1. Pag ang turn ratio is greater than 1, it is a step-up type. Kapag ang 1 with the turn ratio naman kapag less than 1, ibig sabihin step-down naman yung type na ginagamit natin na transformer. Okay? For example, the equation, ang equation natin is mangyayari natin sa equation is voltage ng secondary is equivalent to N ng voltage ng primary. Ibig sabihin, the secondary voltage of a transformer is equal to the turn ratio. Ito yung N kasi turn ratio natin. That is time natin, times sa primary voltage. Okay? Pag ang turn ratio is greater than 1, ibig sabihin that is step up type. Pag ang turn ratio is less than 1, that is step down type. Okay? Okay, then the peak secondary voltage, BP sec, in transformer couple, half-wave rectifier is the same as BP or input peak voltage. In the equation, BP out equivalent to BP in, then minus 0.7 volts. Okay, then as you can see, written in the term of BP secondary is equivalent to, okay, ito yung equation 5 natin, that will be equal to peak voltage, output peak voltage equals minus ng secondary peak voltage, minus lang natin dalawa. Then minus natin doon sa barrier potential na 0.70 volts. Okay, then para ilipat mo lang siya, since equals to 0, ang magiging equation na natin in the terms of the equation PIB equals to BP in terms of BP sec, ang magiging PIB na natin, peak inverse voltage equals to BP secondary. Okay? Okay, ito naman yung example ng full wave rectifier. Okay, ano ba yung full wave rectifier? Okay, as you can see, ito yung full wave rectifier. We have, for example, we have a sinusoidal waveform, 0 volts. Then, papasok dito sa full wave rectifier. Anong gagawin ng full wave rectifier? A full wave rectifiers allows unidirectional one-way current through the load during the entire 360 degree of the input cycle as shown in the figure 3.7. Okay. Ito kasing full wave rectifier, ina-allowed niya yung unidirectional na one-way current papunta dun sa load during the entire 360 or isang cycle ng input cycle. Then, ang magiging result ng full wave rectifier dito, yung sa output natin, is with an output voltage with a frequency twice the input frequency and pulsates every half cycle of the input. Okay, nagiging half cycle na yung ating input. Nagpa-pulsate siya. Ayan, okay. Nakita? Then, ang frequency is will become twice the input frequency. Okay, then, ang magiging equation natin dito ng voltage average voltage is equivalent to yung peak voltage natin divided by pi. Then, the average value for full wave rectified sinusoidal voltage is twice that half wave value or rectification. Okay, that is the full wave rectification. Okay, ito na yung pinaka-output niya. Okay, how about the center top full wave rectifier? As you can see in this figure, we have an example of a center top full wave rectifier. Okay, as shown in the figure, it is a circuit for a center top full wave rectifier that uses two diodes connected to the secondary of a center top transformer. Okay, meron tayong sa center top full wave rectifiers, meron tayong two diode. Ito, isa, diode 1, diode 2 that is connected of a secondary center top transformer. Then yung input voltage naman is nakakupol through the transformer. Nakakupol dito. Okay, yung input voltage natin. That is coupled to the transformer to the center top secondary. Okay, ito yung sa secondary. Okay, next. Okay, now, how about the positive half cycle for a center top full wave rectifier? As shown in the figure is what happened during the positive alternation of the input voltage. When the sinusoidal input voltage Bin goes positive, the diode 1 is forward bias and the diode 2 is in the reverse bias. Okay, nangyayari dito sa positive half cycle ng center type full wave is when the sinusoidal input voltage ito, Bin, goes positive. Pag goes positive ito, ang diode 1 is in the forward bias. Okay, it means it allow the current. Then kapag sa diode 2 naman, since naka-goes positive naman itong sinusoidal input voltage na Bin, ang mangyayari sa diode 2 is in the reverse bias. It means it blocks the current. Then the current path is through, pupunta dito sa D1 and the load resistor. Okay, doon magpupunta yung current path is through the diode 1 and the load resistor RL. Okay, then this will become the output voltage. Okay, continuation. How about the negative half cycle naman? Kung meron tayong positive half cycle, sa negative half cycle naman ng center top full wave rectifier, as shown in the figure is what happens during the negative alternation of the input voltage. Okay, ito yung nangyayari kapag negative half cycle or negative alternation ng input voltage dito. When the sinusoidal input voltage Bin, okay, dito, goes negative naman, the diode 1 naman, kabaliktaran, is magiging reverse bias naman dito or magiging block the current. Then sa diode 2 naman, it will become is in the forward bias. It will allow the current flow through these circuits or in this diode. Then the current path is through, okay, yung current path is pupunta through the diode 2. Kasi ito yung naka-forward bias or nag-allow ng flow ng current. Then, the current path is through the diode 2 and the load resistor RL. Okay? Then, the output voltage develop across the RL. Dito ma-develop yung output voltage. Across RL, then it is in the full wave rectified DC voltage. Kaya, usually, ang rectifiers convert AC voltage to DC voltage. From AC to DC. Okay, next. Okay, how about the effect of a turn ratio? Okay, as you can see, these are the center top full wave rectifier with a transformer turn ratio of 1. As shown in the figure, is a transformer ratio is 1. Okay, ano mangyayari kapag ang transformer ratio is 1 in the center top full wave rectifier? The peak value of the rectified output voltage is equal to half the peak value of the primary input voltage. Then it's less than the barrier potential. Half of the primary voltage appears across each half of the secondary winding, BP sec minus PP primary. Okay, that is voltage secondary minus voltage primary para makuha yung secondary winding. The forward voltage due to the barrier potential is also called diode drop. Okay. Okay, continuation of the effect of turn ratio. How about a center top full wave rectifier with a transformer with a turn ratio of 2? Kung dito ang turn ratio is 1. Kapag turn ratio is 2, the peak value of the rectified output voltage is equal to the peak value of the primary input voltage less the barrier potential. Okay, yun yung formula. Then the total secondary voltage, V sec, is equals twice the primary voltage. Okay, ibig sabihin ang total na secondary voltage natin, V sec, is equal siya sa twice ng primary voltage. I-times 2 lang natin ito para makuha yung secondary voltage or yung V sec. Then the voltage across each half of the secondary is equal to primary voltage. Okay. Okay, these are the equation of the output voltage for a center top full wave rectifier. The output voltage of a center top full wave rectifier is always 1/2 of the total secondary voltage less the diode drop regardless of the turn ratio. Okay, ito na yung formula ng output voltage natin. That is B sec over 2 minus yung barrier potential na 0.70 volts. Okay, that is for the center top full wave rectifier or the output voltage of center top full wave rectifier. How about the peak inverse voltage of a center top full wave rectifier? As you can see, as shown in the figure above, each diode in the full wave rectifier is alternately forward bias and then reverse bias. The maximum reverse voltage that each diode must withstand is the peak secondary voltage, BP sec. Then the diode D2 is assumed to be reverse bias and the diode D1 is in the forward bias. Okay, ito yung nangyayari sa peak inverse voltage ng center top full wave rectifier. And then magiging formula natin ng peak inverse voltage that will be equals to 2 BP out plus 0.7 na barrier potential. Then this will also equals to naging multiply kasi yung 0.7 naging twice kaya doon sa secondary is naging twice 2 siya. That is 0.7 times 2. Kaya naging 1.4 yung ano na dito yung constant. Kaya equation 10 that will be secondary voltage will be equals to 2 BP output voltage plus 1.4 volts. Okay? How about the bridge full wave rectifier? Ano naman yung bridge full wave rectifier? As shown in the figure is a bridge rectifier that uses a 4 diode connector connected. Okay, makikita natin sa bridge type or bridge full wave rectifiers, meron tayong 4 na diode ng connected here connection. During the positive alternation of the input voltage, the diode 1, yung D1 natin dito, and the diode 2, this one, is in the forward bias. Okay, and it will conduct current in the load resistor in the RL. Okay, ibig sabihin yung D1 at saka dito natin is naka-forward bias dito sa bridge full wave rectifier. Kapag naka-forward bias, it will conduct current. It will have a conduct current in the load resistor RL, while yung diode 3 naman natin, tsaka diode 4 is naka-reverse bias. It will block the current in the load resistor RL. Okay? As shown in the figure also above, is the negative alteration naman kapag sa bridge full wave rectifier. As shown in the figure is what happened during the negative alternation of the input voltage. Okay, as you can see, we have a diode 3 and diode 4 are in the forward bias sa negative alternation. Kabaliktaran naman dun sa kanina sa positive alteration. Dito sa D3 and D4 is naka forward bias. Yung kanina kasi dito, D3 at D4 naman dito is naka-reverse bias. Kabaliktaran nga. Okay, the diode D3 and D4 are forward bias in negative alternation. Kapag naka-forward bias, N will conduct current in the load resistor RL. While yung diode 1 naman natin dito at diode 2 are in the reverse bias, it will block current in the circuits or RL load resistor. Then at full wave, output voltage appear across a RL. Okay, iyan ang itsura ng output voltage. Or a full wave output voltage appear in the RL. Okay, how about a practical diode? Ano naman yung tinatawag nating practical diode sa bridge full wave rectifier? As shown in the figure above is a practical diode model. There are two diodes to be considered that is in series with the load resistor. Okay, meron tayong dalawang diode na naka-series with sa load resistor during the positive alteration. And sa negative half cycle din, ganun din. Then the output voltage, ang formula nito is equals to BP out equals to BP secondary minus 1.4 voltage. Okay? That is a practical diode consideration of a bridge full wave rectifier. Okay? Now we will discuss the peak inverse voltage in a practical diode consideration of a bridge full wave rectifier. Okay, ano yung PIB dito? As shown in the figure above, diode D1 and D2, okay, are forward bias. Okay, ibig sabihin, it allows the current to flow in the load resistor, and the diode D3 and D4 naman is reverse bias. Yung counterpart nito is block the current. Then in practical diode model considering the diode drops, okay, may diode drops tayo na 0.70. The peak inverse voltage across each reverse bias diode in terms of BP out, okay, magiging formula nito ng peak inverse voltage natin in terms of BP out or output peak voltage, that will be equals to output peak voltage plus lang natin yung 0.70 volts or yung barrier potential or yung the diode drops. Okay, these are the schematic circuit for a PIB practical diode consideration of a bridge full wave rectifier. Okay, kaya nagka-additional na 0.7 dito. Ito na yun. Kasi nga meron tayong kino-consider na diode drop or barrier potential. Okay, these are the end of our lecture.